Alright, let's talk about univariate influential outliers. Outliers need to be checked for their influence. It's okay to have outliers, but what you don't want is an outlier that strongly influences your estimates and biases them in an overweighted way, meaning that one data point has more influence on your estimates than other data points. It has undue influence. So one thing we can do is go check box plots. That's a pretty simple approach. So let's go to Analyze, Descriptives, Explore, and get those variables we were using. There we go. And then just hit OK. This will run for a second and then produce all sorts of statistics and box plots. Scroll down, and here's the box plot for efficacy 1. Outliers will appear beyond the whiskers of these box plots. So efficacy 1 has no outliers. Efficacy 2, no outliers. 3, here we go, has some modest outliers. I say modest because they are represented by circles rather than stars. I'm not exactly sure the cutoff in SPSS, but this would equate to something like beyond 2 standard deviations, whereas a star might be 3 standard deviations. Here we go, efficacy 4, no outliers, ease of use. A few modest ones. Nothing I'm concerned about. None. A few. None. A few. Let's see if we can find one that has some stars. Probably not, since these are Likert scales. It is unlikely we'll find any extreme outliers on a 5-point Likert scale. Oh, here we go. What is this? Skill acquisition 1. Looks like most people just answered 4. You can see that in the stem and leaf right here. 255 answered with a 4, 33 answered with a 5, and 89 answered with a 1, 2, or 3. So the question here is, are these influential outliers? It is unlikely, since there are so many in both groups. This is still quasi-normal. Let's see if we have any other issues. Fairly normal. Here's another one like skill acquisition 1, but we can see the cases up here, 46 and 57 are on the tails, so it's just a peaked distribution. And same issue here, 44 and 72 on the tails, just peaked. So nothing really to worry about. Now, if we were using continuous data and we observed extreme outliers, we might consider examining those points specifically to see if they are truly aberrant or out of scope. But in this case, this just confirms that we do have a fairly normal set of variables with no major outliers. If we'd like to run a number against that to see if it is statistically significant as an influential outlier, what we can do is go to Analyze, Descriptives, and then put those variables in this box and save standardized values as variables. Let's do this. Alright, doesn't really matter what we do over here, just need to save standardized values as variables. This will standardize all of these variables and stick them in new columns in the data set. That is done, and now if I go back to my data set and go to the right, we'll see all these new ones. They're called Z or Z, and then their variable name. And they are just the Z-score after setting the mean to 0 and the standard deviation to 1. Then, if we see anything beyond 3.3 as a Z-score, then it's beyond 3.3 standard deviations, meaning it is truly abnormal. So let's go over to that variable that we saw some oddity on, which was skill acquisition 1. And let's sort, right-click, sort ascending, and we see, -4s, so those truly are far out there. And then if we sort again, but descending, we can see on the top end there were none that were truly extreme. Now, the question is, what do we do about it? So, if I sort again ascending, we can see it was just 4 respondents that had truly extreme responses on this variable. 4 out of 381 is probably not going to change anything when the value is just beyond the threshold of 3.3. So in this case, I'm probably not going to do anything, but I will tend towards more robust methods and bootstrapping to diminish the influence of these outliers. In the next video, we'll talk about sample size.